The environmental scanner function for Digitron 4000 is supposed to read sensor data. So on this video tutorial, you'll learn how to do just that on Android. To give you a head start, I've prepared some content for the front page here. I've put it into a layout file called sensors.xml. This contains a linear layout, which is oriented vertically and contains a succession of label text fields and table layouts. Those table layouts consist of table rows, and each table row consists of one or more views. In these cases, that's one text view for the label and one text view for the data. On a related note, the number of columns per table layout is specified by the table row with the largest number of views inside. In our example, this number is always 2. If you look at the layout, you may notice that neither table rows nor the enclosed views contain any width or height attributes. That's because, by definition, all children of a table layout fill their parents. Regarding the sensors, this layout already hints at the fact that there are some sensors that report 3 values corresponding to 3 spatial dimensions, whereas other sensors, such as light, proximity, and temperature, only report 1 value. I've included this layout fragment into the main.xml by using an include tag again. Since the content of this include is far too large in height to fit this page, and would thus push this view here out of vicinity, I have wrapped this include in a scroll view. The scroll view takes up as much space as it can and will automatically scroll its content, the include. So much for that. So now let's hit the code. I'll double-click on main.java to open the main Java class. In this Java class, I've already prepared for you a set of helper methods down here. These helper methods leverage the tasks of either marking sensors as not available by entering respective values into the appropriate fields, or for entering the sensor data into the text fields when a sensor is available. For finding out if a sensor is available and for leveraging the sensor data, I'll need a sensor manager. Since I'll need the sensor manager throughout the class, I'll define the class member. Private sensor manager sensor manager. I'll initiate this sensor manager in the onCreate method. Sensor manager equals getSystemService is a method which returns instances of system managers components. Scroll down to sensor service. In order to be that of type sensor manager, I'll also have to cast this to sensor manager. Hover over this squiggly line and select Add Cast to Sensor Manager, like this. The next thing I got to do is find out if the desired sensor exists on this system. Let's start with the accelerometer. I'll call the sensor manager for a list of sensors of type accelerometer, like this. Let's organize the imports by hitting Ctrl-Shift-O on PC or Command-Shift-O on Mac. So I define a list of sensors and ask the sensor manager to retrieve that list of sensors of type accelerometer. This type is conveniently defined as a class constant in the sensor class. If there is a sensor, which means the list has items and its size is greater than 0, then it does something. We come back to that later. If it doesn't retrieve any, it will just mark the sensor as not available in the respective text fields. So if there's a sensor, which I know when I'm in here, I'll ask the sensor manager to retrieve the one which is the default sensor, because there could be more than one. If you place the cursor within the brackets and hit Ctrl-Shift-Space on PC and Linux as well as on Mac, you'll see the method signature. The first parameter would be the listener, the component, the class, which listens to the events of the sensor. And here I tell, okay, this will be this class, this instance of this class. The second parameter, of course, is the sensor to listen to. And the third parameter is the polling interval, which means the interval in which the sensor is checked for changed data. It's recommended to set this interval to as large a value as possible, because polling the sensors certainly adds up to the power consumption. But in order for this class to function as a sensor event listener, this is also supposed to implement a specific interface, the sensor event listener interface. So hover over the squiggly line and select Let main implement sensor event listener. This will add the implementation statement to the class signature. If you now hover over the squiggly line and select Add unimplemented methods, it will add these methods to the end of the class body. If you want to specify where this method should be inserted, just hit Ctrl+3 or Command+3 on Mac. Select Override Implement Methods. And there you have the sensor event listener, and on accuracy changed and on sensor change pre-selected. I want this to be inserted right behind the onCreate method. So I select in the insertion point drop-down after onCreate bundle and click on OK. In this example, we don't care for accuracy changes, so here we just do nothing when the accuracy of a sensor changes. If indeed the sensor data changes, the listener method on sensor changed is called. And in that case, I make use of my helper method and write the values of this event, which I get from the event object, into the respective text fields. There's the curly bracket missing here. That fixes it. Bracket and a semicolon as well. So the event object has a property called values, which is an array of values. The first value is the x value, the second is the y value, and the third is the z value. To make this a little more readable, I'll create some class constants to alleviate the reading of those values. Value x, y, and z with the respective numbers. And now I can replace this with that, which makes it a little more readable. Let's save and start. You can see the accelerometer values are indeed red. Of course, these are simulated in the emulator. To read the other sensors as well, all you got to do is retrieve their respective lists of sensors of that specific type, for example, gyroscope, temperature, light, or whatever. Register the listener. You can take the same, which is this class, for the default sensor of that type, or just mark that sensor as not available if the sensor manager doesn't retrieve any sensors. So in the end, the onCreate method would look like this. You can see it's always the same stuff. Get the list, in this case of sensor type gravity. Read the values or mark as not available. The same for gyroscope, magnetic field. For light, you'll have only one value. Proximity and temperature, all following the same pattern. And since now the change of data of any of these sensors result in this event listener method to be called, you'll have to factor out this part of the code and amend this event listener function with a switch statement, like this. So in this method, you'll first check the type of this sensor and call the respective method, handing in the event object. And these functions for those different types of sensors all look the same, like this. They all write the sensor values into the respective text fields. And since most of the sensors are not available on an emulator, let's save this file and start it on the device. There we are. Accelerometer, gyroscope, magnetic field, and light. Let's cover the light sensor. Well, it's reduced. It comes back again. And that completes the environmental scanner for the Digitron 4000.